So the recording is also on. Yeah. So welcome to my second tech talk. And in this topic, I'm about to cover what is message broker and why and how. Basically, what I'm trying to cover is what is message broker and how we can better use of this message broker. So we'll jump into the session. And so here's the agenda for today. What is the message broker and basic concepts, model of the message broker and message brokers in action, why actually we want to use it, common use cases, and what are the popular message brokers, and how we can better use it, and what are the drawbacks and in the message broker. So let's go to the a message broker. So, what is a message broker? A message broker is an intermediary computer program module that translates a message from a formal messaging protocol of the sender to the formal messaging protocol. So, there is a word called formal messaging protocol. I'll explain you down the line in the session, but keep in mind there's a word called protocol and it's formal messaging protocol. And what is actually message protocol? Imagine uh, you want to send a parcel, a package to one of your friend. So without thinking whether he will be there or not, without considering of your recipient and his availability, we are going to the post office and drop it there. So whenever he's available, that parcel or package will be delivered to him. So message broker is also work as same. So let me go further and I'll explain more in bit. And again, message brokers are called integration brokers or interface engines. As you can see the below image, there are words producers, consumers, queues. I'll be explaining those. Yeah. And basic concepts of message brokers. Yeah. Basic concepts. Though so producer is the main concept. Producer, they're the responsible for sending messages to the message broker. So whoever the sending message to the message broker, it will be producer. And yeah, I'll explain another thing later. And again, consumer. There are the ones which get the message request from the message broker and then consumes them and provide a response for those, right? And queue. This is a data type. It's the data type that we are used in our message broker to store messages in our message broker using FIFO logic, first in, first out. And exchange. Exchange is a configuration layer. It's like an entity which sits on the top of the queues and grouping the queues and routing the messages to the relevant recipient. And bindings. Binding is a link between queue and exchange. And the routing key is a message attribute. The key, the exchange look at when deciding how to route the message queues. So these are the basic concepts: producer, consumer, queue, exchange, binding, and routing key. Producer and consumer, when we go to the message brokers, there are models of message brokers. Uh, there are two models: point to point and publisher subscribe. So there are two models of this message broker. So in publisher subscribe model, we call this produce consumer and producer as publisher and subscriber. So again, there's a concept called exchange, which routes to the message to a corresponding recipient and grouping the queues. So this exchange, we have three type of exchange: direct, fan out, topic. I'm not going to do like deep level explanation of on these basic components of this message broker. So this direct exchange, the message is routed to the queues whose binding key exactly match the routing key of the message. And fan out. A fan out exchange routes message to all the queues bound to it and the topic. The topic exchange does a wildcard match between the routing key and the routing pattern specified in the boundary. Yeah, in this exchange types, mostly we are using topic exchange, and I'll explain it later with the example. And talking about models, yeah, there we have point-to-point messaging broker model. So what is this point-to-point message broker? Yeah, message queue have a one-to-one relation with the message sender, which is producer, and the consumer. So in this case, messages are stored in the queue until a consumer is ready to process them. Only one consumer consumes a specific message on its process. It's removed from the queue. So once it is removed, it will be removed from the queue, and no longer any recipient won't be able to, any consumers won't be able to consume this message. And this is suitable for payroll and financial transactions. And the other model is publish subscribe. It's called pub sub method. And in this model, message queues have a one-to-many relationship with the message sender and receiver. Also, the sender is known as a publisher and the receiver is known as the subscriber. In this case, not like uh, point-to-point method, here message is open to whoever's subscribed to this queue, he can get the message. And this is where we get, in this method only, we get the exchange topic. Point-to-point method, we are not, we can't have topics. Only publisher subscribe method we can have topics. And according to this model, a sender publishes message on a topic. These messages are distributed among all of the consumers that have subscribed to the topic. So based on this topic, the messages will be redirected to the subscribers. And this is suitable for an airline systems. Yeah. So the message broker in action. Actually, how this message broker is working. So the message broker sends a message to the broker. Let's see a message broker in action actually. How we are going to send the messages. A customer place an order. The order service immediately send a message to the broker. The broker stores the message reliable until consumers are ready. Consumer receive and process the message, but the broker store the messages and route the message to the relevant subscriber. As you can see below images, queues mean point-to-point model and the pub sub mean publisher subscriber method. Both are sending messages, but again, we are sending publisher or producer sending messages to the message broker. From the message broker, will be the consumers and subscribers are there. They are waiting. Messages is getting sent to the queue, and once the queue is filled with messages, they will be consuming and they will be sending responses. So that is how message brokers are in work. Yeah. So why actually use it? Uh, why actually we want to use it? Imagine a situation we have two services in two different servers. And again, we can have these two processors in one server want to communicate with each other. So how, in that case, what are the options we have to use? We have REST APIs and RPC, likewise, other communication methods are also there. But why actually we need message brokers? It's because it separates the system. It's like dependability on each other systems. It will be in using message broker. We won't need we won't be able to do that. We don't need to worry about the other systems and everything. We don't need to worry. So it separates systems so they don't depend too much on each other, making the whole system stronger and less likely to fail. And message delivery is guaranteed. Even though the consumer was not active or offline, the message will be delivered when active. It's very important when it comes to IoT devices like aircraft and likewise. System performance is increased with asynchronous processing. Processes that take a long time can be processed separately, and therefore the main thread of the application will not be affected. and applications to communicate with each other, even if they are implemented in different programming languages like Java, SOAP, REST API, IoT devices, whatever the without depending on program languages. Even though if the other party is failed, we don't need to worry because the messages will be delivered to the consumer whenever it's get online. And again, prevent messages or data being lost and parallel processing. As an example, I can say, just imagine a flight system, airline system. It's a particular flight is about to delay, so we can send a message that that a tower can send a message that this flight is getting delayed. At the same time, cabin crew will know the situation and the flight control and the guides and everyone will be the system all connected to the that plane, that airline system will be affected, and they get the message and they consume it and they can do their work parallelly without waiting the other task. Yes. So common use cases of this message brokers. So why actually we use this common message broker actually? Not just to send notifications. No, it's not like this. Earlier, when it comes to message brokers, like we were using only to send notifications, but not like this, not like all days. Now we can use like send notification, running background task. Brokers are like all are used to run the background tasks, like generating reports, redesigning reports, uploading images. Likewise, we can do that. And when it come to IoT devices, when it come to IoT devices, we can get the sensor data, bikes, events, data logs. Likewise, we can get the data. Even though IoT devices are offline, we can send the messages whenever they send pulse or we consume messages. We can do that. And order and payment workflow, when it comes to e-commerce like Alibaba, uh, uh, eBay, when it comes to these workflow, whenever customer places an order, at the same time bill gets generated, emails are getting sent, seller get the notification. Likewise, workflow will be going on, keep going on, the process parallel working, and the banking and the logging and monitoring pipelines, collect, analyze the alerts, and event driven microservices. This is the high level version of the message broker, loosely coupled system reacting to the events. Like whenever we have the message broker within our system, it is very important to consider why we are using message broker, and when we are using message broker, we need to have this loosely coupled systems within the other parties as well, if we are involving third parties. And uh, popular message brokers. Uh, Now I have listed three popular message brokers. All of them are open source and free versions. So these are not just only the message brokers that we have, but again, these are the very popular and again mostly used in within our industry. So RabbitMQ. RabbitMQ is one of the most famous and mostly widely used open source message broker software, and it is written in Erlang and it's supported by the Pivotal Software Foundation. It provides a common platform and a secure location for your application to send and receive messages. And practical examples: eBay, Shopify, SoundCloud, likewise, uh, is using RabbitMQ. And Kafka is my second choice as a popular one. Kafka is a robust queue broker and open source messaging system. It is a distributed event streaming platform that can handle a high volume of messages. It's also using Alibaba, Uber, LinkedIn, Netflix, other common current using Kafka message broker. And ActiveMQ. ActiveMQ stands for Active Message Queue, was developed by Apache Software Foundation in 2004. ActiveMQ and Kafka both are Apache and both written in Java, supports Java systems. Yes. So this is the quick comparison of the selected message broker versions. RabbitMQ is mostly used in task queues and workflows. Kafka is used in event streaming high throughput. Throughput means number of messages can consume per second. And enterprise ActiveMQ is used in enterprise JMS integration. And RabbitMQ mostly used for microservices, asynchronous jobs. And Kafka is using real-time analytics and big data processing likewise. But ActiveMQ using Java applications, legacy systems. Um, RabbitMQ use broker and queue-based point-to-point message. And Kafka use distributed log stream. ActiveMQ using broker queue-based messaging. And throughput, when it comes to RabbitMQ is very medium, Kafka very high, ActiveMQ is medium. And RabbitMQ reliability is high, Kafka also high, ActiveMQ is also high. And again, since we are talking RabbitMQ, let me show you the real example of RabbitMQ. So when it comes to RabbitMQ, let me switch the screen to a different one. Yep. So I hope you can see my Cloud AMQP screen. So when it comes to message brokers, now not just only message broker providers also there. Now this is a very simple example. Cloud AMQP is providing RabbitMQ by themselves, and again AWS they also providing RabbitMQ within their uh, uh, a service as Amazon MQ, and again SNS. Likewise, there are different providers also there when it comes to message brokers. Now, Cloud AMQP is one of the uh, message broker, and now as you can see, this is our test environment portal, and this is paid version. And this is very easy. You guys can install RabbitMQ locally, or you guys can log into this Cloud MQP and log into a free version. Then you guys can create this account as well. And again, when it come to here, uh, there are so many options when it comes to RabbitMQ. Now, as you can see, there are options, versions, configurations, plugins. I'm not going to go all of these options, but I'm going to give you a high level idea of this application. Using this provide application, we can configure plugins. At the same time, we can configure cluster and firewalls definitions. Likewise, we can do that. And again, once you create a RabbitMQ environment, you will get a host simply like this. And again, with the host, you will be getting a username and password. And again, not just this, you can access to RabbitMQ using REST APIs. You can first you need to download this connection file, and then you have to upload it, and then you will get a file. Then security key. Based on that, you can connect to these REST APIs, and then you can configure these options. And let's go to RabbitMQ console. Yeah. So this option might different based on the provider that you are using. Now, once you log into RabbitMQ console, so you will get this kind of a screen. So here you can see the RabbitMQ version and the developed Erlang version. So currently, what I'm showing you, it's using RabbitMQ 4.0.9, Erlang version 27.3.3. Now, this is the version why I'm explaining why I'm considering these versions. Yeah, it is matters because now very first when I'm starting I was telling you about the protocols. Yes, now that is where it is coming from. These protocols we are using protocols AMQP and MQTT. The difference is it's lightweight, and based on the industry and the consumer, like if it's IoT device, we are using MQTT because it's lightweight. If it is AMQP, we are using because it's very complex, and it can handle uh, any large, not MQTT also can handle, but again, when it comes to AMQP, can handle more than MQTT. And again, it's delivered like guarantees very, when it comes to AMQP, delivering messages is very guaranteed in AMQP. So these AMQP versions and MQTT versions are very matters when it comes to the RabbitMQ version, that you need to be careful when you are configuring your RabbitMQ instance. Yes. So let me jump into the overview. So this overview shows you a number of queue messages that you are getting, and it's like a dashboard of your console. So it's showing you the message rates and everything consuming, and likewise you'll get an idea. And again, you can import, export the messages, definitions, queues, everything within the console. So we have few tabs. So one is called connection. In this tab, it shows us what are the devices or what are the producers, publishers connected to this RabbitMQ console. And again, you can't connect directly. To connect, you have to have a user account. So if you go to admin account, admin tab, you can see the users there. So in here, you have to have a routing key. I have explained that routing key. Using this routing key, we will be connecting to the RabbitMQ console, and this is the exchange. So once we click on this exchange, as you can see, there are topics. So these are the topics we have, and these are the bindings. So this is the routing keys, bindings, and these are the exchange. Right. So we'll go to queue, and this is the queue. So as you can see, there's a queue, and here you can see number of messages received, total incoming and outgoing, you can see. So if you click on the queue as well, you'll see the number of messages you have received, and again you can send message, and again you can receive message, you can delete, likewise we can do. And again, so these are the most commonly used, and if you are using a free version of RabbitMQ, then these are the features you get, like only these features. But if you subscribe to paid version, then you will can go to these virtual host policies, clusters, shovel, likewise you can connect to these. uh, this virtual hosting, you can have separate environments within a console. And policies, you can add policies. Using these policies, you can add like auto clear option to the queues. And again, using limits, you can limit the number of messages within a queue. And shovel management is like, let's say you have a different two RabbitMQ consoles, then you can send you can pass messages from one console to another console, right? So this is the high level idea of the RabbitMQ, and I think you all have got an idea about the RabbitMQ console. And yes, again, if you go to documentation, you will get the information you need, and again, you can switch the version based on your requirement. And again, you can install this RabbitMQ locally as well, and again, you can run CLI commands. But again, when it comes to web providers, RabbitMQ providers are limiting their accessible when it comes to web versions. When you have it installed, RabbitMQ installed in locally, you have the full control, and you can do whatever the configurations you want. But again, if you are using RabbitMQ web version with a different provider, then there will be a restrictions that you when you might occur some issues when you are configuring, then you have to raise support tickets with this RabbitMQ provider, then you can get help. Right. So let me go back to the presentation. And yes, now how to use it better. Now, how to use it better? It actually matters because even though we have a system, even though we used a message broker, we should careful when we are considering and having a message broker within our system. Let's say we have a system which sends message and communicates every time, but there's no rush. There's no like the when it comes to volume, we don't have much length. Like we don't have much messages to send. In that case, we don't need to use message brokers. We can use simple REST API calls or any other method. Likewise, we can do that. So consumers should handle duplicate message safely. That's the main thing when we are having a message broker. That is the main thing that we need to be careful because uh, even though message sending, like the consumer delivering the message, even though it is guaranteed, there can be duplicated message. So handling duplicates is very difficult when it comes because let's say we have IoT devices. Let's say we have Pygmy or Uber bikes send messages like 100 messages. So it can be duplicated without considering the time. It can happen. So handling the duplicate is very difficult. It should be do within a very careful manner and set clearly retry and dead letter queue method policies. There's a concept called dead letter queue policy. Don't lose fail messages. Like even though message failed, we should try to capture and review them. We should like to retry and send likewise and right tool for the right job. That means there's a situations that we need to use Kafka. Like Kafka is for streaming, RabbitMQ for queues. Like we should not use RabbitMQ for streaming purpose and Kafka for queues and background jobs. So likewise, we should use the right tool for the right job and monitor and alert. That is very important thing when it come to monitor and alert because whenever we have a very rushed hour, whenever we have not expected messages, if the queue is got overloaded, then the entire RabbitMQ or entire message broker system is going to shut down. Like it's going to stop because of the process overheating. So we should monitor and alert the system, and we should be very careful when it comes to monitoring and alert. And keep messages small and lightweight. Now, why we are asking to small and lightweight? Yeah, it can handle the message weight, but again, we should not send large amount of package, large amount of data set within a message. Uh, and again, we should not use message broker as database. Even though a queue is storing messages in a first in first out logic, we should not use message brokers as database. We can use it as a message broker, but not as a database. We can just pass only reference IDs, go like some sort of a unique thing to get data from database without passing the entire table record. And correct protocol for the communication. Like if it's a IoT device platform, we should use IoT device supported protocol. And if it's a non-IoT device application, then we should use non-IoT device supported protocol. When it comes to protocols, now we have latest version of the AMQP 091 and 1.0 is the latest version. And again, MQTT 5 is the latest version. Now again, we have 3.1, 3.2 likewise. But when it comes to IoT devices, we should be careful when we using correct protocol version. Right. And what is the drawbacks of using message broker? Yes, added complexity. Now, even though we have the message broker, it is working and it's getting done, it's handling the pressure, handling the weight. But again, it is adding complexity. Why? Uh, Now it's just earlier, if we were using REST APIs or some other thing, it just directly send the request and we are getting the message. That's it. But now when if we are using message broker, then infrastructure configuration monitoring is there. We have to have a set of infrastructure. We have to calculate the number of servers, clusters, nodes, and again the RAM. Likewise, we have to consider that, and again configurations, firewalls. Likewise, we have to uh, consider that, and the monitoring. If it is earlier just load balancer, now we have to have a monitor at least. We have to do a 5 minute, 10 minutes monitoring time to check the message broker is working the way we want. And again, adds extra layer, not always suitable for the real time low impact project. But again, when we are adding producer broker consumer method into our system, that means we are again adding an extra layer. And again, operational cost, need servers, scaling, and pay for more managed services, like other as I said, providers. Likewise, and monitoring and debugging difficulty. It should be like very easy to handle very like large number of messages, but again harder to trace the message flow compared to direct API calls. We can just add a debug point and we can see, but again we can't see once you send the message to the message broker. We get the message has been sent, but again if we go to the message broker, message won't be there. That can be happen. That is very difficult point. Yeah, again obviously message will be delivered, but again if there is a issue or misconfiguration within the message broker, we won't be able to identify. We have to do more digging. And message ordering and duplication issue, guarantees depend on broker type. As I said, point to point is like one part, one producer sending a message to one consumer, but publisher subscriber sending one message to the whoever subscribe to that queues, like many subscribers. So whoever in that system has access to that queue can consume this message. Again, can be duplicate, and ordering issues are there. And learning curve, it's not very easy. Like whoever planning to implement message broker into their system, they should have to have a better understanding about how the topics, queues, policies, likewise every configurations, how it's working and how the message broker is working within the system and how it's communicating within the system. So those are the drawbacks of having using and message brokers. Yes. So that's all about for today's session. Do you have anything, any questions or feedbacks?
I think the last slide is the important. I think that overall it's good, unless if you don't need that, I think it will kill you. Like when it comes to especially the debugging and all, this will kill you. Like even for a small issue, you can't pinpoint where it is the message and all.
Yeah.
But the concept is good. We have to choose only if we have to go for like asynchronous model where that cannot be replaced. Then anyway we have to go. But I think otherwise, like this will be like it will add some more complexity. That is the main thing.
Yeah. Okay. Yeah. If there's nothing, we can wind up the session. Okay. Thank you guys for joining. And have a good day.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you. Bye.